Are you tired of your data pipelines breaking in the middle of the night? Or how about paying for servers that are just, well, sitting there doing nothing? In this explainer, we're going to show you a much better way, building serverless data pipelines right on AWS. We'll demystify the whole thing so you can get back to focusing on what actually matters, your data. So, does this sound familiar? You're spending way more time managing servers than you are actually analyzing data. Your ETL jobs decide to fail at 3 in the morning, and your cloud bill is, well, it's all over the place. If you're nodding along right now, you know the pain of traditional server-based data pipelines. It is a constant headache. But what if you could just say goodbye to all that frustration? Well, that's exactly where the serverless paradigm comes in. It's a completely modern approach that gets rid of the servers, scales on demand, and, this is the most important part, lets you focus on the data itself. Honestly, this is a total game changer for data engineering. Okay, so what do we actually mean when we say serverless ETL? It's simpler than it sounds, really. It's just a way to build these data workflows where you, the developer, never have to think about the servers underneath. The platform handles all of that for you. It scales up when you have a mountain of data to process, and it scales all the way down to 0 when you don't. And here's the kicker. You only pay for the exact compute time you use, not a second more. You know, the benefits here are about more than just the tech. This is a fundamental shift in how you work. You stop being an infrastructure manager and you get to be a business logic creator. Automatic scaling means you're always ready for a sudden spike in data. The pay-for-value model is just common sense, right? Why own and maintain a car when you only need a ride? All of this just massively reduces your operational overhead, freeing up your brilliant engineers to build cool stuff instead of patching servers. And the result? Your team becomes incredibly agile. To really wrap our heads around this, let's follow a single piece of data as it makes its way through our pipeline. I always find it helpful to think of it like a factory assembly line. We're going to start with some raw materials, transform them into a finished product, and then ship them off to the warehouse. So the journey starts right here at the factory's loading dock. This is the ingestion phase. Raw files, we're talking CSVs, JSON, log files, you name it, they all arrive here. And our universal landing zone for all this stuff is Amazon S3. Why? Because it's super durable, it's basically infinitely scalable, and it's incredibly cost-effective. It's the perfect starting point for pretty much any data pipeline you can dream up. Next up, our raw material moves on to the main assembly line. This is the transform step. This is where we take that raw, kind of messy data and turn it into something genuinely valuable. We're going to clean it, we'll validate it, enrich it with other data, and structure it so it's ready for analysis. This is where the real magic and all the heavy lifting of the pipeline really happens. Now, what's really cool is that AWS gives you different tools for different jobs on this assembly line. You can think of AWS Lambda as your precision laser cutter. It's perfect for quick, event-driven tasks, like a new file lands in S3 and a Lambda function can fire up instantly to process it. On the other hand, you've got AWS Glue. Think of that as your heavy industrial press. It's built on Apache Spark, and it's designed for these huge, complex, large-scale batch jobs. We're talking massive data sets. So choosing the right tool for the job is one of your first key decisions. And finally, our finished product comes off the assembly line, ready for the warehouse. This is the load step. The clean, transformed data gets loaded into its final home. Maybe that's a data warehouse like Amazon Redshift or a search service. At this point, it's all primed and ready for your dashboards, for machine learning, and for generating some real business insights. So, we've got our assembly line. Ingest, transform, load. Sounds pretty simple, right? But what happens when things get complicated? What if one of those steps fails? Or what if you need to run 10 jobs, but they have to be in a very specific order? See, a real factory doesn't just run on hope. You need a floor supervisor to manage the entire workflow. I absolutely love this quote because it is so brutally honest. Without proper orchestration, you're just kicking off a bunch of scripts and hoping for the best. You've got no real visibility, no automated way to handle errors, and zero resilience. A single failed job can bring your entire operation to a grinding halt. And this is where AWS Step Functions makes its grand entrance. If our Lambda and Glue jobs are the individual musicians, each playing their part, then Step Functions is the conductor of our entire serverless orchestra, making sure everybody plays in harmony and right on time. So as you can see, Step Functions does a ton of the heavy lifting.
It manages the exact sequence of your pipeline. It automatically handles errors and retries, which is huge. It even gives you a visual workflow, which is incredible for debugging. You can literally watch your data move from one step to the next. It also manages the state between functions, passing info along the way. In short, it's the resilient glue that holds your whole pipeline together.
All right, now that we have all the pieces of our pipeline and a conductor to lead them, it's time to start thinking like an architect. Because you see, it's not enough for our pipeline to just work. It also needs to be efficient and cost-effective. And that means you have to understand the critical trade-offs between cost and performance. This slide here shows the key levers you can pull to optimize your pipeline. And it's all about finding that sweet spot for your specific needs. For instance, with AWS Lambda, sometimes giving a function more memory makes it run so much faster that it actually ends up costing you less. It's wild. For AWS Glue, you can fine-tune the number and type of worker nodes to perfectly match your workload. And for step functions, you can use something called express workflows for high-volume tasks to dramatically cut your costs. It's a constant balancing act. All right, we have covered a ton of ground, from the big picture ideas all the way down to the nitty-gritty details. So to pull this all together, let's finish up with a super practical design checklist you can use as a blueprint for your own serverless data pipelines. First up, the core components. For ingestion, really think through your S3 strategy. How are you going to organize your raw, processed, and error buckets? For transformation, make that critical choice we talked about. Is this a job for the precision of Lambda or the raw power of Glue? And for loading, please make sure your destination is structured correctly for the kinds of queries you'll be running. Don't make your analysts' lives harder. Next, orchestration and operations. These are the things that separate a hobby project from a production-grade system. Are you using step functions to build a resilient, visible workflow? This next one is huge: independency. It's a fancy word for a simple, vital concept. If you have to run your pipeline on the same data twice, will it mess everything up or will it handle it gracefully? And finally, monitoring. You have to fly with instruments, have solid logging and alerts so you know the second something goes wrong, not when your boss calls you. So there you have it, a blueprint for building powerful, scalable, and really efficient serverless data pipelines on AWS. By embracing this serverless way of thinking, you can finally stop wrestling with servers and start focusing on what really matters: your data. The possibilities are absolutely endless. So the question is no longer, can we build it? The real question is, what will you build with it?